Now let's discuss about very important pattern, which is multi-step processes. So this is very hard to achieve this and understand. So understanding it's very critical and to handle in distributed systems, because with the first hand experience on real product development and on calls and all, we know what it takes to have a system and support this, and having ability to reset back and then try to have a workflows that can run for days and wait and all those things and all. So let's try to understand why, because why is it so hard to build in real production systems, because they must survive failures and retries and long running operations waiting for hours or days. So these are this is what it's called through multi-step processes, which involves like coordination of multiple services and systems. So that's the challenges, so that's the problem. So let's try to understand basically what in the real world how it might look like. So consider an example of simple example that we can all connect to: order fulfillment section. So let's say we have an e-commerce order fulfillment workflow. So what we do basically, usually charge payment, and once this payment is done, we try to reserve that inventory so that it will not be booked by others. And once we reserve that inventory, we need to create a shipping label for that, and then wait for some a warehouse worker or some delivery candidate to pick the item, and we need to send the confirmation mail. Those are the series of the steps. So now you see that basically this is what I was like charging payment and reserving inventory, creating a shipping label, pick and pack, and then send confirmation and wait for the pickup and all. So these are the steps, they're all tied up together. So assuming now even if one step fails in between, how do we handle those things? Okay, so here basically each step it involves calling different services or waiting on humans in the loop, or any of which might fail or timeout. So and some systems, for example charge payment, we mostly call out to external systems like Stripe or also other gateways, and wait for them to complete. So during these orchestrations, our server might crash or anything might happen. So now how do we handle this messy complexity of all this business needs that comes up in whichever the domain that we are trying to handle? So here we need to wait on this gateway, and here reserving inventory. If it's unavailable, again we need to initiate this refund, and if it's not able to create a label for that, if some machine is down and all, should we raise a ticket or so? And again here sending confirmation, it could take an hours. And here as well pick and pack, basically the pickup guy can come after an hour or so, or after a day, or after a few days, or whatever it is. An email failed, should we retry, and all those things. So these are trying to patch each step. So we need to have mechanisms to retry and have the compensations actions that we can undo the thing that we just did using that step. And also we need to have delayed queues, and all these things basically are the steps. So how do we handle all of these situations is what comes in this pattern, multi-step processes. So mostly you will see this in these days with AI systems heavily adopted all this multi-step processes, and you will see every tool call approval or rejections and all those things, that's also step. And all sandbox agents, background agents, and in popular systems that we are already seeing in payment systems and in Uber systems and all those things. So let's see how can we deal with this thing, how do we handle and all the solutions. So the solutions, let's try to see all the possible approaches that we can see. The first is basically single server orchestration. So the simple thing that we can do is try to orchestrate everything from one server, so trying to call each service in sequence. That's the only thing. So basically our the API server, the server, individual server that normally we usually start with, it will get an order from a user. So here we have it will get an order from user, and we'll just walk through steps in order. Basically what we do, we try to charge the payment and reserve the inventory and create a shipping label and send the confirmation email. So that's the flow it's going to look like. So the single server that we try to handle all of this for things, and payment service, of course, will receive webhook response and all those things. But the problem is here, assuming everything is happy path, and we assume that we never have to do anything with scaling and all. This is exactly, it's a good path and to start, and we'll say okay, this is fine, it's working fine. But this has two serious problems. Reliability guarantees, that's one, and of like more complex coordination. So first thing is crashing and the failures. So what happens if this server goes down, the only one that we are trying to rely on? So maybe like, let's say we charged payment, and before trying to reserve this inventory, that step server crashes, and now when it restarts, it has no memory of what happened and all again. So we charge the customers and we have not delivered any product and all. And this callback routing here, this webhook gateway payment gateways, basically we'll try to give them the webhook endpoint, so they try to hit our hosted endpoint, and then we know exactly when payment was successful and event change, and then we try to update metadata in our DB so that we know if the payment has been made or not and all those things. But here let's say if we have scaled out our the server, then how does it know to which server to send it to, and that callback can land on completely different host than the one that started the order. And now that host has no idea like which in-flight order the callback belongs to, and all those things. So that basically we can usually patch that up using this approach called pub/sub, introducing that. So here we try to now persist the order state to the database. We'll maintain this order state DB after each step that we complete. So now no single host has to remember it exactly, and route callbacks through what we do. We try to do using this this webhooks or whatever it is through pub/sub. And so whichever server is free can load that order and continue where the last one left off. So this would look something like this, trying to handle now with state, maintaining DB, and pub/sub for callbacks handling and all that stuff. And now we still have a few more problems to solve even with this approach. So with multiple API servers, who picks up the dropped work? Okay, so that's the thing. And also compensation is still unsolved. Like if inventory reservation fails, now we need to refund the amount, right? And even if shipping fails, we need to release that inventory reservation and all those things. Like the successive steps needs to undo the prior steps and all those things. So that is what it's called, the compensation actions or something of that sort. So where do we go from here? That's where like we have the patterns called the Saga pattern. So Saga is nothing but it's a detailed series of events, like that's where like series of sequence of local steps where each step has a matching compensating action that undoes it, and we try to run the steps one at a time, and if later one fails, we try to walk backwards, firing those compensations to unwind whatever already happened. So that's the thing. And there are basically alright, so there are two ways to coordinate Saga, one through choreography and another through orchestration. The one that I really like and we adopted is orchestration. And choreography is basically there's no coordinator at all. So each worker subscribes to events it cares about and does its piece and emits new events for the next worker to react to and all. That is a classic example for event sourcing, which here I have listed down. We'll walk through that. And other is basically orchestration, so where a single orchestration owns the flow and tells workers what to do and all, because the whole sequence lives in one place. Now orchestration works best for very complex workflows. That's what like the durable workflow engines like Temporal and all we are using. Even I use extensively at work and all those things. Okay, so let's talk about event driven choreography here. So basically choreography, the thing is basically here I wanted to let's give you a brief thing, the source for that. So like instead of storing the current state, what we do, we instead store the stream of events, that got us to that specific point that we are in. So then let workers react to those events to drive the process forward. So the most common way, like basically adopted at work to store this durable log is basically Kafka is a popular choice, although this Redis streams could also work in places. So that's where like event sourcing, that's like closest match to that. So event sourcing, what it does, it tries to treats the log as a source of truth and derives state from it. So and here we are trying to use the log to coordinate work. So they basically often travel together but don't have to. So let's try to understand what this is. So basically here we have this client and API server, everything whatever we wanted to write, we'll try to write it to event store. So we'll have these topics, order, payment, inventory and shipping, and whenever we try to write event of the specific thing, the workers will automatically pick up and do the job. So here we have the payment workers, inventory workers, shipping workers, and everything happens, the event will trigger, will pick up this workers and does the job. So that's what this event store basically tries to take in the double duty. So it holds the entire history of the system and also it drives the next steps. So whenever something happens that we need to react to, we write an event to the store, and these workers whoever are here, like ordinary services like processes, subscribe to this log, consume events, perform their work and emit new events. So for example, if you take a payment worker, it sees basically order has been placed, so now and calls our payment service. So and when the payment service calls back later with the status, the payment worker whatever you have, it emits like payment changed or payment failed, and that will be seen by this inventory worker, and it emits like inventory reserved or inventory failed and so on. So this compensation also flows the same way, just the backwards, so that now payment worker will also be subscribed to like inventory failed and reacts by doing the necessary thing like issuing a refund and emitting payment refund and all. So here now you see here API server now is just the thin initiating wrapper around this event store, and when the order comes in, we emit an order placed event, and the system springs to life to carry the event through the system. And then rather than services exposing APIs, there are now just workers trying to consume events from our store. So this is a thing, and what we get out of this event sourcing pattern is basically gives us fault tolerance. So worker consume the log as long as they are actively able to connect to our consumer group, as a log, and they can do their process and all those things, and easily we can scale each individual worker. And observability, so the log itself is a complete audit trail of everything that happened. And flexibility, so appending new reaction is pretty easy since it's just new worker consuming existing events and all those things. But here what we do is we need to build the infra, the event store that I'm talking about, and the queues, and also the orchestration and the debugging event and all. Everything is pretty hard. That's again the trade-off and all. That's one way. The other is basically the workflow thing, the workflow orchestration. So here for orchestration, this workflow is basically a reliable long running process that can survive failures and continue where it left off. So this is basically is what the durable execution engines that I was talking about. Temporal, like popular open source preferences. Everybody is trying to adapt into their systems, especially when AI boomed and all those things. Okay, so here basically we need to understand few things here. Durable execution is basically a way to write long running code that can move between machines and survive system failures and restarts and all, like instead of losing all progress whenever even server crashes or restarts. This durable execution systems will automatically resume workflows from their history databases, like replaying events and all those things, and then resume from the step they are supposed to actually continue and all. So let's basically here that's what, like, workflow is durable resumal process, event sourcing plus state management, and no hand rolled infra and all those things. So here the best thing is, it's like we write everything like code. So durable execution engines, like not like it's a declarative, it's a complete imperative, and greater control for developers, whoever is trying to build the systems. So for example, Temporal, and we have the here other managed workflow systems, like step functions and airflow and all, which are not of greater flexibility, but that works. That's not my favorite and all, but both give durable execution and checkpoint each step, and can resume on a new host after a crash and all those things. So let's see now the example for the Temporal. So we try to write the workflow as a code. The engine basically tries to replay from this history to recover and all those things. So here the important jargons that we need to understand is few things: workflows, activity. We need to understand what are they. So here let's take an example. Trying to understand workflow. This is the high level flow of like our system, and here activity is basically one step in that flow. So picture the, like, let's say we can picture workflow as completely the ordered steps and the decisions between them, and activities as simple individual actions that can touch the outside world, like calling to a DB or talking to payment external parties and all those things. That is the activities are what we can call. So, and one thing we need to understand is basically few principles. Workflow must always be deterministic. Basically, given the same inputs, we always get the same it takes us to the same path, and it always makes the same decisions. And when it comes to activities as well, it needs to be idempotent. So let's say if it's DB write or any other things, no matter how many times we do, it gives us the same result. So we need to make sure that what's the key that we are going to use and how we are going to maintain those things, so that it's safe to attempt retries. That's very important, right? So that is why, like, and why the determinism and idempotent that I'm trying to stress is here. Recovery, how recovery works is by replay. So every activity result is recorded into history database that will be managed by that Temporal itself. And if a workflow, let's say the runner which is running the workflow crashes, then another runner re-executes that workflow function from the top. So every time the replay, it's an activity that's already run, the history hands back that result instead of running it again. That way, like, instead of running, we try to get the result from the history DB, and so because the code is deterministic and no activities refire or replay is that's what, like, gives us assurance that no side effect will be there, and execution lands exactly where it is left off and all. So that's the thing. So for example, let's take an example here, order workflow. So here we're trying to start the process payment, and it runs and it lands its result lands in history, and then the reserve inventory runs and its result lands in history, and then server, let's assume that executing the workflow dies. So now what happens? A new worker picks up the workflow and tries to re-execute the workflow all the way from the top again. So now at the process payment, the history already has the results, right? So now engine returns it without calling the payment service again. So that's how, like, it tries to get from history DB. Same at the reserve inventory and it gets it, and now it reaches the ship order, and it knows that we have not executed that, and now it continues live from that exact point that crash interrupted. So here now we are guaranteeing that the customers are charged once, the inventory was resolved once, and none of the business code that had to crash is affecting any of the workflow. So here basically, and also a very important concept here, the signals in a workflow will offer a greater flexibility for a workflow to wait for an external events. For example, let's say human in the loop, like human approval, or else like webhook listeners and manual inspections and all those things. This is something that we can wait and all those things and all. And here the temporal deployment, we need to understand what components that we have. So here we have few things. So the temporal cluster, we need to talk about this. So the things that you'll have is temporal server, that's the actual bookkeeper. So basically it hands out like tasks, tracks timeouts and records like progress and all. It basically, it doesn't run on any of our code. It's by default its functionality. And the history database, very important, the append only log of all workflows, decisions and activity results and all those things. And here we have workflow workers, basically the pool worker pools. This is where the processes that we run hosts our actual code. So the workflow workers, they run workflow function to decide what happens next, and activity workers that we have execute the activities and all, where they can talk to external services and all those things. So this is how it's going to look like at a high level. Overall, the temporal deployment is the thing. And so we have besides the temporal that I was talking about, and we have this managed workflow systems, though I have not used extensively, but the difference between that is, temporal and here is basically we try to define here the workflow as a state machine, okay, or a DAG in JSON or YAML in this format, this stuff. So AWS step functions and Google Cloud workflows. And basically if you try to do in this, the advantage is basically we can try to visualize as a diagram, which is a nicer UI to see. And also like it's less expressive than code, which is very bad thing. So, and we don't have no flexibility, and again it's a deviation from the code and all. Anyhow, but these are all not handwritten, they will be generated by AWS CDK and all those things. But that's the thing. My favorite is temporal. And now let's talk about this the implementations. So which one to pick based on our preferences. So temporal is the most powerful one, like I mentioned. So it's a true durable execution. So here we can operate our own cluster in K8s and self-host and all those things, or else we can just use temporal cloud and all. But we mostly use self-hosting option, try to have manage in our own K8s. Another is the step functions AWS offers, which is serverless on AWS, and this is a JSON state machines, and it has limits and all, 1 year durability and 256 KB data payload size and all. And then these durable functions are in the Azure or the Google Cloud workflows, similar functionalities and easier to run than temporal infra overheads and all, and less flexible. And Airflow, basically they are good for ETL tasks, extract, transform and load and schedule batch, not really for event driven programming. So default I would say stick to temporal, and others if you want you can just choose that. Okay, now the question is basically when should we use and when not to use. So whenever we see there is a state machine or stateful, then by default like we go for this is the multi-step process, a multi-step pattern, and then see if we can think in the terms of workflows or activities, and think of temporal and how can we act that as a gluing between of our all services and all those things and all. So So that's the thing. So if sequence of steps needing a flow chart, then definitely that's a pattern, and we just try to use this workflow engine, like try to centralize state at one place, and retries and compensation, make sure that determinism and all the principles, activities, and all those things and all. So yeah, so that's the point to look for. And now let's try to see few scenarios like deep dives and all. So here the most at least well-known examples is payment systems, because it has to deal with a lot of state management, like for example refunds and waiting for the approvals, and third party MasterCard or other things and all. So those states and all those things, and human in the loop, for example, especially in the AI agentic systems, for anything that is destructive in nature and all, we exclusively ask for accept edits or approve or reject and all those things. Those are like patterns. And also like besides that, you AI Uber or like rider waits for driver to accept that, so there's again human in the loop. Again, that's the multi-step pattern and all those things. These are all basically great examples or use cases for our the workflow related stuff. And so basically they shine wherever the stateful processes must complete reliably or roll back cleanly, like all the way back to step 0 and all. So those things. And yeah, fine. And let's see now. So for example, matching workflow, Uber matching. So what we do, loops over like nearby drivers until one accepts. So we'll have the rider service, driver service, and here assuming here we have the matching workers, so it will try to try to wait for this driver to accept and all. So here basically we try to propose to nearby drivers one by one, and on accept we try to notify the rider, on reject timeout, and we'll try to try the next. You see here we can now use the standard code looping of the drivers list and all normally into our code as a workflow, and this is a great flexibility for the developers, right? So that's the thing it provides, and that's the just the example. And when not to use and don't even think about is basically if it's a simple asynchronous processing, straight away big no, and we can just straight away use a message queue and all those things, for example resizing an image or sending an email. And if it's a like a synchronous operations, so if a client waits for the response, and there's a lot of sensitivity around latency and all, you never even think of this multi-step process. And same thing, high frequency and low value operations workflows, they really add over it, and there's a big no. And these are the situations like big no for multi-step processes, and don't try to adapt this pattern and all. So now let's try to see few situations. So updating the running workflows. So here's the situation. So basically let's say we have like 10,000 workflows are running and mid run, and now we need to add new step. So how do we take care update these things? So first approach is basically a versioning concept. So here what we do, we try to deploy a new version separately, and old runs finish on the old code, and simple, and basically there's no in place change and all. This is like safer bet. And other is basically migrations. So here this is a pretty complex. So what we do, we try to update the definition right in place, whatever we have, and then we have a concept like called patch to branch deterministically. So this is how, like for example, we check here this patch to call whatever we have returns true for new executions, so they run this the new behavior. So the executions whose recorded history already extends past this point from running the old code and all, it returns false, and it stays on the legacy behavior whatever we have. So that's the thing, versioning and then migrations, to see if we wanted to add new step for the existing ones, and how to adapt the new path and old path. And that's one thing. And the other situation is, how do we make sure the workflow state is small? So here basically we know that durable engines process the whole history and replay it, like states can like very fastly balloon this. How do we handle? So always try to keep the input as the shorter, trying to pass in the identifier, so that we can use that to look for the in the DB, or if it's a file path, S3, pass that instead of the actual bytes, and then you can get the file in the activities logic and all. Or if it's a file system that we are talking to NFS and all, pass the path and try to read in the activity logic and all. So that's the thing, not payloads. And we try to store big data in DB or external, and we'll try to keep the activities inputs and results small. So or else there is a concept called continue as new. So we try to basically periodically snapshot a long running workflow, and try to add a fresh copy to a new temporal workflow, and we try to continue as new from that state, instead of all the way starting from the step 0. So that is the two ways, continue as a new, and make sure that passing identifiers are not payloads. So that's the thing. So we try to keep smaller activity input and output, and the periodic recreation keeps that replay fast and history bounded. So that's the thing. Okay, fine. And the other situation is, how do we deal with external events, and how do we wait for it? And this is where the important topic that we need to be at least aware of, signals. So we need to wait for human or webhook for minutes or days without consuming resources. And let's say for example we are waiting for signature and all, so we can wait up to wait for a signal like up to 30 days or so, instead of relying on the polling and all. So in that case, what we do, we try to define a signal and set handler to that, and basically create one variable and try to set the data in the callback. And we then put a condition, call the condition until the signature is not defined, wait for this 30 days, and if we don't get still after even 30 days, again set a reminder for that document ID, and again wait for 7 more days, and if not, we can just cancel. So that's the thing, the process signature and all. Then this basically what signals do, they suspend the workflow efficiently, so there's no polling, no resource use and all. And this way, like we are not awaiting on a thread or blocking a thread or CPU consumption and all those things. So that's the thing. And the how do we ensure that no matter how many times we retry, that impact of that step is the same. So how do we ensure? So that is the thing, making it an idempotent. So idempotent is basically the key should be very unique, like for example email or and also have the picked by that activity by checking on the status, like after completed, like if it's completed only try to pick it up, and so that's trying to make the idempotent and store an idempotent key, and we try to even check before the reversible action. So that's the thing, so that we ensure it's all atomic and all. Why the status maintaining is also needed, like it's completed or in progress and all. Let's say we are trying to do some shipping and all, and that process can die after maybe charging payment and all, but before recording that actual idempotent key. So in that case, that is where that marking that key as in progress or completed really helps, not just idempotent key and all. So this is what, like before sending, if keys email order 1 2 3 already exists, we skip, else send, then store the key. So that is the overall thing. this multi step processes and workflow, durable engine, temporal, and all those things. So conclusion is basically this. So workflows engine helps us to turn the fragile manual orchestration into this robust observable process. So look for these things. If we are hand rolling state, retries, and compensation, then that's the definition for workflow, and just try to adapt to this temporal also. And durable execution code example, temporal or managed, we have two ways, and prefer the way that your stack really adapts to, and they survive crashes and deploys and checkpoints, replays, resumes, and new host, and all those things. So we have signal for workflows. So undo step 5 if x fails, or all steps complete on undo. Okay, so this is the conclusion and the learnings from this pattern. And yeah, hope you get the intent of this pattern, and know at least now where to use and all.